Welcome everybody to the first IGC Events webinar focused on geothermal, which is presented by Think Geoenergy and Enerchange. My name is Jochen Schneider. I'm the Director of Enerchange and glad to welcome you and Daniel Mölk, the Country Manager, Indonesia of the STEAG. We are overwhelmed by the great interest to the first focus on geothermal, which can also be attributed to Daniel and his network. There are up to 300 registrations from all over the world, and we hope you all have the chance to follow this session. Focus on geothermal is the evolution of the German webinar Blickpunkt Geothermie that we started at the beginning of April during the acceleration of the COVID-19 crisis. The idea is to keep in touch and find new possibilities to inform and connect. As the feedback, especially via LinkedIn, was so impressive, we decided to change from a weekly German webinar to a fortnightly webinar in English and German. This means next week there will be again a Blickpunkt Geothermie about insurance solutions for geothermal projects, and in 2 weeks we present again a focus on geothermal, then shared by Alexander Richter from Think Geoenergy. But what will happen now? Daniel Mölk will give a presentation and is available for your questions in the following discussion. Please send short direct questions via the chat function and I will give them to Daniel to answer. Normally, the Q&A session is limited to 15 minutes after the presentation. However, as there are so many participants, we might extend it to 30 minutes. The whole webinar is recorded and will be available next week on our YouTube channel. We will send everyone a link by email. We also adapt you to the newsletter for the next focus on geothermal on June 12, 2020. And please follow us also on LinkedIn and YouTube and Twitter, and award the webinars with likes or comments to improve ourselves. And now it is a great honor for me to welcome Daniel Mölk. He is one of the many geothermal experienced Icelanders spread everywhere in the world with a perfect German, so that I tried last week to nationalize him. We met for the first time more than 10 years ago when he was with Iceland Drilling at one of the first IGC events in Freiburg. From Iceland Drilling, he went to Manvit as drilling supervisor and drilling engineer and moved 10 years ago to Dahldrup and Söhne in Germany. Since 2014, he is the vice president for geothermal at the STEAG, a German utility, and the country manager Indonesia as the president director of the STEAG subsidiary PT Sejahtera Alam Energy. Daniel will speak about the project development in Indonesia. The floor is yours.
Yes, thank you very much for the introduction, Jochen, and welcome, ladies and gentlemen, to this presentation. The purpose of this presentation is to provide some guidance based on the experience we have made with our own development in Indonesia. It is mainly from the perspective of an operator or developer, but I am sure that many of the issues that I will show can be also transported and relevant for other parties interested in the Indonesian geothermal market, like consultants, experts, lenders, insurances, or service provider. The target is to point out issues that are, in my opinion, specific for the Indonesian market and the Indonesian country when developing a geothermal project or being part in a geothermal project, especially in comparison with projects and companies in North America and Europe, since this is the perspective that I personally have and that STEAG, the development company, is located in. The topic of geothermal development is very widespread, and therefore I will try to give an insight in technical issues, geological issues, operational, commercial issues, and also in some regulatory aspects for the Indonesian power market and the regulatory framework to be active in Indonesia. Since this widespread is so big, I look forward to many questions after the presentation. So the agenda is I will give you a very brief introduction about STEAG, the development company, and why STEAG is doing the geothermal development in Indonesia. I want to introduce the general framework conditions in the geothermal market. Then I will give you an insight in the Baturaden Power Plant Project and summarize it with a specific nature for geothermal development in Indonesia, ending up with the conclusions what I think geothermal interested parties can learn from our experience. STEAG is a German energy supplier that is based in Essen, Germany. It is one of the biggest power utilities, but behind the big four that are very dominant in the German energy market. The key figures are shown in this slide. It is mostly worth to mention that STEAG has been operating for a long term also outside of Germany in international markets with a widespread of different energy technologies and power plant operations, thermal and renewable. And the roots of STEAG come from the mining or coal mining business, being in Essen, Germany, the biggest mining region of Germany, that by nature did bring some closeness to geothermal development. And in the past, STEAG has also been part of geothermal thermal projects in Central Europe, mainly in South Germany, and has in Indonesia with the Baturaden project started the first project for power utilization on geothermal. Besides that, the activities are on every continent, and STEAG is operating own plants in Europe, South America and Asia, and therefore has a good, let's say, baseline to enter also the geothermal market in Indonesia. The framework conditions in the power market in Indonesia are in general very promising. Indonesia has an installed power capacity by the end of 2018 of about 65 gigawatts. Most of the power is distributed in the Java-Bali grid and the Sumatra grid. This power grid is operated by PLN, the state-owned monopoly for power distribution in Indonesia. The rest of it is distributed by direct use. One of the reasons for that is that Indonesia is simply an island archipelago where a continuous power grid as we know it from other countries on the continent is simply not possible. The power market in Indonesia is growing. The electricity sales have grown 6.4% by average since 2010 and were expected to continuously grow further prior to the COVID-19 pandemic, which has of course also slowed down the Indonesian market. The reason for this high development is on the one hand that there is still a big market on the private users to be connected to power, but Indonesia is also making a transition to more own manufacturing of its resources and goods, where power is partly the bottleneck. From investor side, long-term PPAs and still US dollar pricing are one of the things that attract independent power producers to Indonesia. As can seen here, the geothermal part in the energy power mix is still slow in the Indonesian power market, but it is not insignificant. And it is growing with a target of 2,500 megawatts by this year, which was given prior to the COVID-19 pandemic. But on its own, as shown by Alex Richter in the first webinar a couple of weeks ago, it is the second biggest installed capacity in the world today, with the world's biggest potential that can still be developed. In the future, by signing the Paris Climate Agreement and the planned fuel switch also in Indonesia, geothermal and hydropower could supply 25% of the country's energy demand. The Indonesian government is trying to set the framework conditions to accelerate this agenda or to execute this agenda. One of the key changes in regulatory framework was made in 2014, where geothermal development was taken out as mining business and put under power development business. This change was very important for the geothermal IPBs to come because it centralized the license from the local governments to the central government, and it did streamline more and more regulatory framework to have more predictability for the investment and more security. The important thing to mention, and I will come back on this when we come to the specific local conditions, is that geothermal energy in Indonesia is a natural resource that by constitution belongs to the Indonesian people. And by our experience, this is something that has to be taken into mind and also be respected during the entire development or provision of geothermal services in the country. In the mindset, we are developing the geothermal projects in cooperation with the government, and that's how the relationship should always be structured. The Baturaden project, which STEAG has started to develop, is a project in Central Java, the main island of Indonesia, and it is not yet explored yet, so the plant capacity shall be somewhere between 110 and 220 megawatt electric. The project site is on Mount Slamet, which is shown in the picture here below. It's an active volcano in Central Java. The total invest will be based on the capacity that we can install from the resource. With the range that is given, it is somewhere close to $600 million, up to 980, almost $1 billion of investment. The project is mainly held by STEAG, but by regulation and also by business strategy, we have a local partner in the country that is supporting our development in the country. The project has a signed power purchase agreement, which is on 90% take-or-pay basis to give us the investment security and a validity of 30 years of power sales, which are good conditions for the long-term investment that you have to make in geothermal, and the pricing is in US dollars. This project is also part of a governmental infrastructure program. It's called the 35 gigawatt program. The original target was to install 35 gigawatts of additional power by 2025. I have to say the program is not on track, but it puts some development pressure on everybody that had the benefit to be included in this program. The project area, as mentioned, is on the active volcano Mount Slamet with 3,400 meters elevation. It is in central Java, 20 kilometers north of a city called Purwokerto, which most people do not know, but still has, with its core population and surrounding population, 750,000 people, which is typical for the island of Java, with almost 180 million people living on the same island and the dense population there. The last eruption of the volcano was in the end of 2014 and beginning of 2015. The eruptive events of the volcano are of low impact because it erupts very frequently. Mostly we see eruptions of ash, and if we have lava streams, as you can see in the picture in the upper right corner, then lava streams go for geometric reasons to the north. The two circles you see there are the rockfall circle, which is the inner red circle, and the ashfall circle, which is the yellow circle, just to demonstrate that our development is made away from potential lava streams and outside the rockfall area, the potential one, but within an area where volcanic ash could reach our well pads. The license area with 24,660 hectares is large. As an example, STEAG's home base is Essen, Germany, and the area of the entire city is smaller than this one geothermal license area. And what you can see on the lower picture is everything that is green there is forest area. So it is typical for Indonesia to be developing in a remote area. This is a very quick summary of the geological setting of Mount Slamet. Most worth mention is that we are in an area where two tectonic plates meet, and those tectonic plates put the entire area under stress. It's the Indo-Pacific and the Australian plate that are diverging against each other, and that did, among others, lead to a frequent collapse since the mid-Quaternary age of the crater of the Mount Slamet, which is demonstrated with the different colors of the lava streams coming from different time areas, and making this project also from a geological perspective quite interesting and challenging. And it's the reason for the high elevation of the crater. When you start the geothermal project the first time in Indonesia, or you start to look at a potential participation in a geothermal project in Indonesia, in most cases, people realize how remote the areas are and that they are difficult to reach. In our specific case, we had to improve the conditions of the last 18 kilometers of the existing public road, which is the road from the main, let's say, highway, even though it's more of a smaller highway, up the volcanic mountain. And to realize the arrival of trucks for drilling rig and later for power plant, land had to be purchased, private land, to widen the road. An example is shown in the picture here, where you can see in the lower part of the picture that we have widened the road with concrete there, to realize turning radius for the trucks to come. And you have also to do very much of maintenance, because those roads in those remote areas are not designed nor constructed for such a big development. In our case, which is sometimes the case, we even had to build a bridge to pass a river. And the Baturaden project is located behind a tea plantation area, which had only a rudimentary road. And there we built a completely new road into the forest, which was heavy works on the other side, which gave us the opportunity to build this road based on our specific needs and purposes. I have here pictures to give you an impression about the location of such areas. In the left picture, you can see the bridge that we constructed. There is a big steel pipe where the river flows through, and around the steel pipe we did build gabion walls to resist the weight of the drilling rig later. And the main part of this road has a width of 4.5 meters, not giving trucks the opportunity to pass. So if a truck is on the road, there can only be trucks going uphill or downhill, and that requires many logistic challenges. On the forestry road, like I mentioned, we were able to construct more generous roads where trucks can pass, but of course also then in exchange the civil works required to achieve this were not insignificant. The well pads and future power plant are located in the Baturaden project after passing this tea plantation in a forest. And this forest is very, very remote, which gives some advantages. You might also see in other geothermal projects in Indonesia that you're not having direct impact to a population. That is project specific. There are also large scale power projects like in Sumatra, where you are very close to villages, but we have the benefit to be developing without neighbors, if I may say so. But of course you have to cut your trees in the forest. You have to do a revegetation 2 times the area of space that you utilize for your development. And on those volcanic areas, you have very rough topographic conditions. So this picture that I'm showing, it's an actual picture, like all the pictures in this presentation, from our development in the field. The height of the cut slopes there are about 60 meters. One of the reasons is that is also the steepness of the volcano. The distance, the direct distance between our first 2 well pads is 2.4 kilometers, but you lose about 800 meters of elevation between them. And such roads have to be built in a way that in the end of the day, drilling equipment and drilling rig can be mobilized through it. To give you an overview, what you can see in the left part is a very thin red line. That is the public road to the project area. Then it is followed by a very thin green line. That is the tea plantation road. And the bigger orange line, that is the road in the forest that has been constructed already with the first 3 well pads, well pad C, well pad H, and well pad F. And the blue road that has been drawn in this picture is our future infrastructure design. To give an impression on the location of well pads in such an area, I have pictures from well pad H. the first well pad we drilled from in the left picture, with the volcano and the forest in the background, and well pad F, which is the right picture, during actual drilling operations. And I think they represent what I said before, the challenges when it comes to infrastructure on so remote locations. When it comes to drilling, which is one of the biggest cost factors for geothermal development, also in Indonesia, you have the access to a very professional and well existing drilling market, mainly because Indonesia is an oil and gas producing country. This means also that the prices for drilling, like in most countries, are impacted by the demand of the oil and gas industry and consequently from the oil and gas price. And like in most countries developing oil and gas, you have high restrictions or high requirements for safety and logistics to operate drilling rigs. And that is making geothermal drilling in Indonesia very cost intense. That's one of the factors that is impacting or limiting the speed of geothermal development in Indonesia. It is the country with the most expensive geothermal wells in my opinion. And the reason for that is that you need a high amount of logistics because you're on an island archipelago. Drilling rigs have to be transported with by maritime way with trucks through those remote areas. But also you have some to import almost every piece of equipment. The good thing is you have a very good market with good people in the country. Our experience during drilling, the specific conditions when we started to drill the campaign, was that we had a difficult surface part in the hole where we lost almost continuously our mud. We had boulders coming into the well and leading to damages. And we had also later clay that gave us a hard time. The good thing is, and that's the good thing, that you have an oil and gas market in place and that you have professional contractors in place. All the challenges that were faced could be resolved. In our case, it was the implementation of air drilling and stiff foam drilling, of non-continuous circulation systems, of change of bit technologies and very specific Siemens slurries. But one of the key that, in my opinion, did realize the drilling of those very difficult wells was a fast decision-making process within the group, which is, in my opinion, one of the core conditions to do geothermal drilling successfully. This is just a very quick slide about the original well design to show that in Indonesia, like in most high enthalpy geothermal fields, the standard well design can be used. Later, during exploitations, many operators then make specific adjustments based on the brine composition and the enthalpy. For example, in Sumatra, they use additional casings, but also bigger size casings. But when you do exploration, you have the opportunity to use standard well design and therefore a good access to equipment and to materials. This is just a picture very quick to show the potential hardness of geothermal rock in Indonesia. When we drilled through the lava and had problems, we used the technology, or we tried the technology of casing drilling. And this is a PDC casing drilling bit. And both pictures show the same piece of equipment, prior installation and after installation. And as you can see, it was not successful. In this case, the rocks that were to drill did defeat the bit, leaving it behind more like a wok than like a good piece of drilling equipment. This is just a picture that shows the beginning and the end of the drilling of the second well, which was the deepest geothermal well that has so far been drilled in Indonesia. When it comes to the reservoir and exploration, this picture shows the different exploration activities that we have done. We have started with the well in the middle called SMT H1 and H2. They're both from the same pad. The first well had to be abandoned due to technical restrictions. There we needed to adjust tools and technology. Then we drilled this very deep well until 4,446 meters with very good temperature results, but very low permeability. The development was very much driven by geophysical interpretation that did lead to the decision to drill the next well further south, which you can see on the right side of this slide, well SMT F1. But the geophysical anomaly drilled into was not hydrothermal alteration clay. It was a sedimentary intrusion that pushed from the south into the area. To make it short, it was not successful. And currently we are preparing the well that you see on the very left side from well pad C, well SMT C1, which is supposed to enter this potential reservoir we show in the picture. That is the result of a lot of the data analysis and reinterpretation after the exploration activities so far. So based on our experience and the framework conditions mentioned before, I want to share my personally nature or framework of the Indonesian market for geothermal, based on the experience and also as a guideline what we think is very specific for Indonesia. The first thing very much worth to mention is that from the authorities, especially from the Ministry of Energy, we experience very much support. They are very solution oriented and they share the same interest like an IPB to develop fast and to solve problems. For foreign investment companies, there's also a so-called Foreign Investment Coordination Board, which is developing more and more to a one-stop shop for permits and licenses. They have even introduced now an online system where you can apply for most of your smaller permits online with given time frames on response time. Some licenses are still given by local authorities and there is no standard process. Sometimes it is not clear who is responsible for what. That can lead to time loss. And not all permits are synchronized in between each other. For example, there are some permits that are for your entire development project, but permits connected to that are separated between the exploration and the exploitation phase of your development. Power sales, when it comes to investment, is of course the key. Our experience, or my personal experience also, is that we still do not see a standard PPA from PLN for geothermal development. And this leads in the end of the day into time-consuming negotiations, even for existing PPAs, because they need to ensure bankability and requirements are in most cases not met with the first draft or first signed version, especially when the lenders start checking the requirements and addressing their needs. The tariffs can still be expected to be attractive. There has been an up and down in the price tariffs. The PLN also tried to introduce adjustments for the uncertainties of geothermal development, for example, price adjustment clauses based on capacity, but they are not clearly written and they lead to uncertainties during the development that are uncomfortable. In Java, very often the operator has to provide the grid connection. That is an additional project and task that has to be adapted. And PLN and also the state-owned company Pertamina Geothermal do develop their own geothermal projects, and there is always the risk of a competition with private power producers in the country. For the operations, the biggest thing to highlight is the remoteness of many fields, which makes, in combination with the rough terrain, logistics, time, and construction very challenging, and in the end of the day also have a high cost impact. We always say that logistics and warehousing for drilling are exactly the same like offshore drilling. You have to have all your tools and equipment on location, pay rent for everything on location, because you have no access on short notice to the things that you might need. One of the things in Indonesia, it has for some jobs still a limited talent pool. So you have to choose talents well when starting in Indonesia. When it comes to the specific geothermal expertise, Indonesia has educated its people very well, and geologists or drilling engineers with high qualities are available in the country already. And they have the same challenge like in every geothermal country today. The easy projects are gone, I would like to say. So the nature of geothermal projects is that they are getting deeper, they are getting more challenging. On the other hand, the industry is also getting more experienced. Social aspects are things that have to be always taken into consideration when doing business in Indonesia. In addition to the points that I have put in this slide, it has just to be underlined again that developing geothermal energy as natural resource is developing in cooperation with the government, and there you have a specific social and community responsibility, not only to build your power plant, but also to make sure that this will be a benefit for the area that you're moving in. On the other hand, the lenders, especially if you get development banks involved, will have the same requirements anyway. So what are the conclusions? The conclusions are that just by its potential and energy demand, Indonesia remains the place to be in the future for geothermal development. The market is also profitable if it's well managed. Mismanagement can be a story of unsuccess in Indonesia. So it's no plug and play system that you can adapt. You have to adapt to the country and to the environments, like I showed before. You need a good mix of the local expertise, but also international experience outside of Indonesia for the development to be most efficient and especially most economic. Geothermal is never an investment if you're a consultant or you're a developer for a short-term business, but especially in Indonesia, it is long-term business. What you get from the authorities and from the energy ministry is a lot of support, but they expect you also to pay the support back by the commitment to make your investment and drive the geothermal project further. That's the symbiosis you enter into Indonesia. And for the future, that's something that I just want to slightly mention here. The market is unknown. I know that Indonesia is drafting new regulations. Right now, they have the idea potentially to do the part of the exploration by the state, which can be an opportunity because it decreases the risk of geothermal developers. But if they do so, then there will be no new projects available during the next years. So if somebody wants to enter the Indonesian market as investor or consultant or service provider soon, my personal assumption is that we have to focus on the existing projects, preferably with power purchase agreements in place, because the window might be closed for some limited time to enter into new projects. Yeah, I think that was trying to give you a very brief and quick overview about this very high complex issue, in my opinion, the geothermal development in Indonesia. And I'm very much looking forward to the further questions and hopefully clarifications that you can provide.
Okay, Daniel, thanks a lot for this very impressive presentation. Perhaps we could stay with the slide of your conclusions and start with a lot of questions which came already during your presentation. We have a first question that we got this afternoon by email. This is apart from giving us a general update on the progress of the Baturaden project and any particular difficulties, I would like to ask for his views on the pending new regulations on geothermal, such as we know them and the very recent news of the collaboration between PLN and SMI. I think the first part you just answered, and then there is the question about the collaboration of PLN and SMI.
Yes, I think it's a very, very good question. In general, my personal opinion is positive on the collaboration between PLN and SMI, because we know SMI has had access to development funds for quite some time, but did so far not manage to engage with the party and with the framework to provide the funds. And with PLN and SMI collaboration, in general, it's I see it very positive that SMI has certainly found a way for the fund provision, and also that we have a new geothermal project starting. I can mention that 3 geothermal concessions were tendered last year, but not one bid was received. So if they're starting to adjust the way they're doing it, from my side, it's a positive sign into the market.
Okay, thanks a lot. Then there is another question. We heard rumors that PLN would revise the PPA that has been signed with geothermal developers due to COVID-19. Does STEAG have a PPA in place, and if so, how would STEAG would react to any PPA revisions by PLN? Keeping in mind the PPA for Java Island, where Baturaden project is low already.
Also a good question. First of all, we have not experienced any such move from PLN with respect to our project. So we have not have to prepare or deal for such a situation. And frankly speaking, we do not understand, or I personally do also not understand, the procedure that would be in place to make such a one-sided change. Yeah, the PPAs in Indonesia, they are bilateral agreements. If this, so the only way I can imagine this would happen would be by a regulatory change, and how we would deal with such a situation is difficult to answer at this point of time with this many uncertainties, but it is obvious that you need a certain tariff to keep the economics of your project.
Okay, here fits probably the next question. Could you give information on the PPA price? How much PLN pays per kilowatt hour? How much your estimated cost of production per kilowatt hour are?
The PPA price is public, so it can be shared. It is 9.47 cents. Plus some additional tariff that we get an extra by providing the transmission line for the grid connection. I have to say this tariff is high in comparison to the current tariffs that you can have, and they are low for the Java island, simply because our PPA was already signed in 2014 with this good tariff, and has grandfathering for regulatory restrictions that have taken place since that point of time. Our cost of production are difficult to answer at this point of time because we are still in exploration stage and we have not determined the real capacity of the power plant. So the mix of fixed costs and plant size variable costs are unknown at this point of time, and therefore difficult to answer at this point of time.
Okay, then the next question is also about cost, but also about infrastructure. What percentage of project costs was spent for infrastructure like roads, bridges, and so on?
About 30% of the budget had to be spent on infrastructure, especially for the forest roads, where you move a lot of soil, and the additional measures, of course, you have to take for erosion control to protect the biodiversity and to for example, we had this road construction in the forest. It was not one piece of road construction. We had 6 projects for infrastructure going in parallel that all met at a certain point to finish, and it still took more than a year to build this one piece of road.
So, but these roads and bridges were from this beginning from this T road were constructed by STEAG.
The public road, it was present, but it had to be widened, and there we had to buy some land. The road in the tea plantation and in the forest, that was all constructed by us, yes. And the investment for infrastructure so far has been around 25–30%. During exploration, later when we have the plant construction, it will of course be significantly lower, because the 2 main cost components will be the drilled wells and the power plant itself.
Another question is there a stable utility grid at Baturaden?
At Baturaden right now, we do not have any grid connection. We, the developer, will construct about 18 kilometers of transmission line to connect into the Bali Java grid. PLN will take over the transmission line that we built and pays us then in an increased tariff.
What will be the power generation technology which is applied in Baturaden? Is it a steam turbine or a binary cycle?
Based on the results and the estimations we have so far, we are predicting a single flush steam turbine.
There is the question. From the presentation, we saw that STEAG drilled from 2 well pads. How many wells were drilled, and at what power capacity productions are these?
The 3 wells were drilled, 2 from the first well pad H, even though the first well did not reach its target depth. The reason for that were technical reasons. And for the other both wells, we have not encountered permeability yet. So we cannot provide a power production number based on a production test at this point of time. We have to wait for the next well.
So then there is a question regarding earthquakes. How or is there the danger of a similar event like in Pohang? And how do you prevent something like what happened there?
The seismic activities are always present when you're developing on an active volcano. What we do to mitigate those measures is that we use the civil safety factors for earthquake regions. For example, if you build a slope, then the safety factor is 1.2 without an earthquake, and 1.3 or 1.25, 1.3 if you're in an earthquake area. So you have to increase your design security, and well design and later power plant design take also the strengths for seismic measures into account. We have had seismic events, but so far none of that had led to a road crack or has had any impact with to us or the drilled wells.
Okay, thanks for this answer. Then the next question is, what geophysical method was used in the exploration stage? Which method was very effective to delineate the prospective area?
Mm-hmm. The main driver for our targeting and subsurface model were the geophysical models. So we did, like in most high enthalpy projects, MT measurements supported by gravity and density measurements to come up to determine anomaly of the electric resistance in the ground, determine the clay cap of the reservoir. In our project, the geophysics even played a little bit more significant role, like in other comparable projects, because the geological setting with a high compression of the tectonic plates and the high elevation and sediments from the active volcano did provide less subsurface manifestations than we know from many other projects. So targeting had a very high dependence on geophysical investigations, mainly MT data, so the electric resistivity in the ground.
Okay, thanks. The next question is, can you be more specific regarding the technical issues that you faced during the drilling of the first well?
Yes. The technical issues were in the top hole where the former eruptions from the volcano in the young past did provide, let's say, formations of boulders, so rocks, and those rocks were not very much, we call it cemented, so there was not very much material between those rocks holding them together, and the space between the rocks was porous, so highly permeable. So we had the combination that between those boulders we lost the drilling mud, which had to be cured, and we had so-called total mud losses. And at the same time, the movement of the fluid did destabilize those boulders, which started then caving into the well. So what we did in the end of the day was that during drilling, we cemented into all the space between the boulders with cement that compacted everything and it held them together, and then re-drilled through it, let's say through a hard cement stabilized hole.
Thanks. There is another question. Were the difficulties mentioned on section 4 of the presentation, page 23, known to STEAG before deciding to invest in Indonesia?
You're making reference to slide number 23?
Yes.
Okay. Yes, of course. That's That's one of the reasons, for example, why I did join STEAG, because of its international footprint and expertise in countries like Indonesia. We had, when I came to this project, STEAG had been present with the Singapore hub for 12 years and has already a running plant in Southeast Asia and so on. So when it comes to the geothermal specific things, you always learn something, yeah, independent who you are, who you work for, but also independent which country you come to. But not everything was expected, but let's say the general framework of geothermal development and the country specific and things for Indonesia, they were already analyzed before STEAG decided to enter the project.
Okay, thanks. The next question is, what, in your opinion, can be an effective way to try and identify a potential project in Indonesia, especially low temperature resource location for ORC utilization?
I think the challenge, especially when it comes to this kind of projects, is not the biggest one to identify it. There are maps like I showed in my last slide, and it's public, where all the projects with its predicted potential are shown. If to enter the Indonesian geothermal market for such a technology, my recommendation would always be to start communication with the energy ministry directly, if you have some kind of setup in Indonesia, or to join with a party present down there, a developer or a party close to the business that can identify the project, especially when it comes to the binary power plant projects. The challenge could more be for power sales, because those projects are, many of them are not on the Java, Bali or Sumatra islands. They are on other islands where the geothermal potential is partly high, but you don't have the power off-takers yet present there. So so power sales becomes very often an issue when we are discussing projects in this temperature range.
Okay, thanks. Another question is, when is the next drilling project starting? Because I saw from the slide that not all of the pads has been drilled.
That's correct. Our next drilling is planned from the well pad C, but what we did after we finished the first exploration campaign, we decided to focus on understanding the subsurface prior to moving, and we took time to reprocess and reanalysis all the data. There's also worth to mention that we had the opportunity to measure also the drilled wells, the resistivity and the geophysical properties in those wells, and play the results from the first well into our geophysical subsurface model. And we are happy with the results, but this all did take time. And prior to the next drilling, we are at the point where we are more or less resetting or setting up the project a little bit new. We're doing this in close communication with the energy ministry, because we expect them, and we are in a very good effort, that they adjust our license in accordance to the new needs. We are communicating the new project schedule with PLN, but we are also right now looking at efficiency and opening our project for additional investors to join the development for the further projects, because STEAG has such a widespread agenda with the fuel transition in Germany and the change in the power markets worldwide, that in parallel with with adjusting the timelines for the next development. We are talking with potential co-investors for the project and are doing this in preparation of the next drilling. Having said that, the next well pad is ready, and we have also signed a drilling contract for the next well and are mostly waiting now from the feedback from the other parties.
Okay, there are many more questions. There is one regarding the question we had as first to the market development, and the question is, so do you see this as a medium or long-term opportunity market, well, the Indonesian market?
We think, to say it easy, it's to get into the market is always a challenge because you have to adapt to the specific requirements. So every opportunity to come into Indonesia has to be with a long-term perspective, especially in geothermal, where everybody in the geothermal business has experienced that it's more a marathon than a sprint. But especially when it comes to Indonesia, when you are in the market and you are successful in the development, you are in a very good business environment to stay on long term. And you can also see it on the businesses that are in Indonesia outside of the geothermal market. I'm just making reference to this because there are, of course, much more parties to refer to. When you speak with managers from the oil and gas business or manufacturing business and so on, they all say, yeah, Indonesia is special, you have to learn about it, but nobody has any idea of leaving the market, because when you are in the environment, it's a good environment to stay in.
Okay, thanks. Perhaps try to be a bit more shorter, that we can get through these many questions. Are there any payment security mechanisms for the PPAs?
Yes, there is a business viability guarantee that the Ministry of Finance is supposed to grant with the PPAs that are in place. Having said that, that takes a lot of time, and usually they wait until you have decreased your exploration risk and preferably also can show your potential lenders.
Then there is the question, what type of rocks host the geothermal reservoir at Baturaden? Sediments? If so, what type? Lavas, ash?
The top part is clearly sediments from the eruption of the active volcano. And then the most cap rock is andesite lava, which starts then with hydrothermal alteration as clay cap above the potential reservoir.
Of course, you get also many thanks for your presentation. Here is one. Thank you for the highly insightful presentation. Given the local tectonic activity, is there any concern with the maintaining of well integrity? And are you performing any downhole wireline conveyed casing inspection survey to monitor the well conditions?
We don't think that the tectonic setting has a direct impact on the well integrity, because when we talk about this collapsed craters and so on, that we are talking about thousands of years, not into direct impacts. The earthquake magnitudes are lower than in many other geothermal fields, but so far we have done wireline logging in our holes, yes.
Another question regarding STEAG. Can STEAG invest in other countries apart from Indonesia, like in African countries?
Right now, STEAG is focusing on one geothermal project at the same point of time. So let's say let's bring the geothermal projects in Indonesia to success prior to investigating additional markets. But that's a momentum. STEAG is a very dynamic company, so if somebody has an opportunity, it would always be looked into.
Perhaps I missed the answer. Regarding the Baturaden project, how many wells are planned?
Right now, we plan 5 additional exploration wells, and then the amount of exploitation wells will be dependent on the determined capacity. For example, if we determine a medium case that we looked at for 130 megawatts, we would be in a total of about 28 drilled wells.
And what is the time frame?
We again, that depends on the capacity. The less wells we need, the faster we are, and also how many rigs we can utilize at the same time, because infrastructure is usually a time bottleneck. But we expect to be commercially operating somewhere between 2024 and 27, depending on the reservoir size. Our conservative case right now, especially in the conditions that we are in, is looking at the latest COD at 2027.
Okay, a question related to this: how many megawatt is this project committed and agreed by PLN?
The PLN agreed on a range between 50 megawatts and 242.
And this you're all investing by STEAG?
So far, all investment has been borne by STEAG. Right now, we are looking for a partner to share the investment and the exploration risk. And of course, by transferring into exploitation stage, we are planning a very classic project financing with a consortium of commercial and development banks.
The next question is, there are 2 geothermal manifestations areas surrounding Mount Slamet. We can see Baturaden on the southern part and Gucci on the northwestern part of Mount Slamet. Are those 2 areas related, or are they separated geothermal systems?
First of all, very, very good question. Because that's one of the questions we have been asking us also the last years. Our previous model that we followed indicated that they might be separated. Now that we have started drilling and our model is adjusting, we see the possibility that they might be related. So that's something that we are currently, together with our consultants, looking into very deeply. Also to make the decision if we should start a discussion that the 2 areas should merge into one area or can be developed separately.
Okay, thanks. Then here is the question: after 5 years experience in Indonesia, what would you do differently if you would start from scratch today?
We would, very good question, because
there is another question, perhaps you can combine it. Given your experience, would you take another project in Indonesia?
The first thing, let me first answer the second question, and the answer is definitely yes, because we have learned so much about the country, the market, and how to get things done in Indonesia. And we think that we are in a very vital energy market. So for sure, the lessons learned from Indonesia, there are many. I mean, the most obvious one is very easy. We have drilled wells and there is not yet coming steam out of them. So the different thing the last 5 years I would definitely have started the exploration campaign in a different spot if I would have the knowledge today than 5 years ago.
Then another question for drilling engineering, purchasing and operation. Are you using IPM company or managed by yourself?
We decided to hire an IPM company. We had an IPM contract for the first 3 wells that we drilled, and then we re-tendered the services because it was a 3 wells contract, and we have assigned again an IPM company which is doing IPM in Indonesia for the first time, but could convince us with a quite experienced team on the job.
Okay, thanks. Probably I also missed the answer for this question. When the next well will be drilled, how deep is the geothermal well based on current interpretation?
We expect...
No, these are 2 questions. When will the next well be drilled? And the second question, how deep is the geothermal well drilled based on the current interpretation?
The start of the well will be after we have finalized our conversations with the Energy Ministry, PLN, and also potentially identified partners, because we are trying to, let's say, restart the project from scratch. The depth of the well, the top of the reservoir is predicted to be in a vertical depth of 2,200 to 2,500 meters. So the length of the well could be between 2,500 and 3,000 meters.
The next question, what about the silica concentration of the geothermal fluid? So far, how much is the enthalpy value from your well?
We don't have an answer to that because we have not produced fluid so far.
Is there any surface manifestation in the Baturaden field? And if the exploration include the geochemistry method, how much is the temperature of the reservoir in the Baturaden field?
Yes, we have surface manifestations, mainly 3. We have hot springs in the south called the Baturaden Springs. We have hot springs in the north called the Gucci Springs. And we have a gas seep in the center of the concession with H2S. We were not in the position to measure the reservoir temperature with geothermometers, although we have done chemical analysis of all, because none of the surface manifestations provides saturated fluids. And that's why the drilling and measurement of temperature in the hole was necessary.
Thanks. There is another question. Is there any social problem with local community? If yes, how do you deal with it?
We had, right now we have no social problems, and we did not have major social problems so far. We had an incident where when the rig was arriving, where we obviously did a lot of wear and tear to the public road, and the community around us strongly asked us to repair the roads, which we in the end of the day did, but we needed to explain them that we had to finish the truck mobilization before it made sense to repair the road. As example, bringing a drilling rig to this location, including casings and all the drilling services, are about 200 trucks that you have to bring up this road.
Okay, thanks. How do you manage the unexpected cost and delay in developing the project?
By doing what we are doing right now, we are in communication with the authorities as well with PLN to reset some things, renegotiate some things, which is going well. And we are opening for an additional investor to join us to bring more equity to the project, or from an additional source.
So thanks. Then there is another question. What type of geothermal well configuration did you use in Baturaden?
we used a very standard well design with a 20-inch surface casing, 13 5/8-inch casing, a 9 5/8-inch liner, and then a slotted 7-inch liner in the production zone.
Okay, then a lot of thanks. Thanks for us answering the question. Thank you, and please continue to develop. Don't slow down. Is a comment. Here is another question. You mentioned wireline logs. Does this include borehole image logs as well?
No, so far we have not done any borehole imaging. We were focusing on the resistivity logs.
Another question, has STEAG considered slim hole exploration drilling at Baturaden?
Yes, there was a long process in checking the technology. The challenges were that the infrastructure you needed anyway, which was a big part of the costs, and my personal experience, because the first wells were deeper than 3,000 meters, and you needed 3,000 meter slim hole wells to be to get sufficient information from the subsurface. There was a big question if slim holes could reach economically and safely this high depth, especially when it comes to the torque.
Okay, thanks. And here is the last question. Do you think the area that you drill is an upflow zone or outflow zone?
When I go back to my page 21, we are in, I put the upflow zone in the slide. So we hope that by directional drilling from well pad C and maybe even vertically drilling from well pad Y, we can drill close to the upflow zone of the reservoir.
Okay, then again, thank you very much for this very interesting presentation and a lot of questions you answered. I will advise you to visit our next webinar. It's in 1 week. It's the Blickpunkt Geothermie. It's about insurance solutions for geothermal projects, and it's presented by Achim Fischer-Erzig, who is from the Northwest Assurance. It is in German. The next English webinar will be on June 12th, presented by Alex Richter. Please visit our social media accounts like LinkedIn or Twitter to find out more about the event. You also find information about this on igc.events. Here you also find information about our IGC online meeting on June 17. This deals with the development in the Upper Rhine Valley. Here we have several interesting presentations, and for every registered participant get the chance to have a short presentation about himself and his company. So I wish you all the best for a nice weekend and hope to see you soon here on this channel. Bye-bye.